All right, so we're going to look at 7.5 exponential functions. And our goal is we're going to learn how to graph exponential functions, and then we're going to identify data that displays exponential behavior. This is going to be like exponential growth, exponential decay, and all that stuff. Easier than you think it is. One of the things I think you're like about exponential functions and graphing, you really only need to do 3 points because you'll be able to see with the basic functions, you'll be able to see whether it's going to have a growth or a decay right from the get-go. And one of the nice things you're going to really like is when you have your exponent of 0, because as we all know, when you have exponent of 0, it's 1. So that should be an easy calculation right there. Hopefully from your do now, you explored and you were able to make some discoveries about what an exponential function should look like graphically and everything. So let's jump right into it. So what an exponential function is. An exponential function is a function that can be written in the form y equals a times b to the power of x. You may think, why is it ab? The ab basically just lets it know is like positive, negative, or if you look at the first example, y equals 2 times 3 to the power of x. And if we remember, we always do, in order of operations, exponents first. So you would take 3 to the power of x and multiply it by 2. So this is still an exponential function because we have a value raised to a power of x, okay, raised to some power, well, where x is the power. And as we know, like when we're graphing, the basic form y equals mx plus b, that was a linear equation. And then we had a quadratic, graphing quadratics where the x was squared. So it was like y equals x squared was your parent function there. Now we have another where we have the x's to a power. So these 3 are all different forms of exponential functions. So y equals 2 times 3 to the power of x, y equals 4 to the power of x, and y equals 1/2 to the power of x. And you got to really look at the 1/2 being to the power of x. It's in the parentheses because if it was not, maybe just the 1 is to the power of x. Then it kind of tweaks some things and everything like that. But these are all just different forms or different functions that you could see. If you look at the middle one, you may say, well, where's the a? Well, if you think about it, anything times 1 doesn't change it. So really what this is this is y equals 1 times 4x, right? There's still that number. So there's still that a and that b. Same thing with the second one. This is 1 times 1/2, right? So real simple stuff there. So what are we doing with this? What type of things? Hopefully, again, in your do now, you're seeing that how exponential functions kind of have like a growth. They kind of look like a curved L or a curved J type thing. You're not getting a quote unquote full graph. So if we wanted to graph the following, and we're going to find the y-intercept, let's look at y equals 3 to the power of x. Well, I'm sitting here and I'm going, well, how am I going to graph this? Yes, there is technology. We'll get into technology here in a little bit. But first, the best way to do this is you draw an XY table. So let's get our wonderful calligraphy pen. We're going to draw an X. We're going to draw a Y. Sorry about the not straight line. And everything. And then I'm going to just start with, we really only need 3 points. We need to see points whether it's going to, which way it's going to go here. So I always, my biggest ones I like to use are -1, 0, and 1. And they should be able to be used for pretty much all of our ones we're going to graph today. So let's start with -1. If I plug in -1 in for x, so if I look here, let me grab my pen, I got -1 is x. So I got y equals 3 to the -1st power. Well, now we got to think back to our exponential rules. Anything to a negative power would equal, we'd just have to flip it to get rid of it. So then y equals 1/3, basically to the power of 1. 3 to the power of 1 is 1. So when x is -1, our y value is going to be 1/3. Well, let's do the next one. Let's plug in 0 in for x. So if I go y equals 3 to the 0 power, what's anything to the 0 power? 1. Very good. We should all know as soon as we see that 0 power, we go, oh, look, it's 1. So this one's 1. And let's look at the last one here. If I go y equals 3 to the power of 1, well, what's anything to the power of 1? Well, it's itself, so y equals 3. So when x is 1, we get 3. Now we have the ability, we have 3 points we can plot. And I'm going to see how well my fat fingers can plot on here. So this should be fun. Get my calligraphy pen right here. So the first point, let's go -1. So we're going to go over 1, and we're going to go up a third. So we're going to go up just a little bit and go right there. Wasn't too bad for a fat finger point. All right. And then we're going to do our next one, 0, 1. So we're going to go over 0 and up 1. There's another point. Not too bad. And the other one, we're going to go 1, and then we're going to go up 1, 2, 3. And we're going to draw our point. Hopefully, you guys draw better points than I do. Now, it kind of looks like a straight line, but not really. Because as you can see here, it's starting to create a curve. And one thing I want you to emphasize is these should hardly, our graphs we're going to graph right now, do not go below the x-axis. So your graph should never go below the x-axis. We should have arrows on both ends. Right there. So this is y equals 3 to the power of x. Right, we got right there. Hopefully, again, you guys can do a little bit better jobs of connecting your points. I'm kind of using a fat finger to connect points here while recording. So this is y equals 3 to the x. So when we graph right now, we're going to graph using an xy table. We're going to substitute values in for x. We need to know our exponential rules to solve them. And then it says find the y-intercept. Well, what do we think about what the y-intercept is? What is the y-intercept? It's where the line goes through the y-axis. Well, where does the line go through the y-axis? It goes through the y-axis at 1. So we would say our y-intercept equals 1. Or we could even be more fancy and say it's 0, 1. That's our y-intercept. All right, let's go to this next graph. Graph the following and find the y-intercept. What if we have y equals 1/2 to the power of x? I'm sitting there going, how do I graph this? Well, let's start with our xy table. So I'm going to get my wonderful pen here, and I'm going to draw my xy table here. I wonder if you guys can hear my pellet stove. It's cranking right now in the background. And again, like I said, let's plug in our -1, our 0, and our 1. Easy numbers to use right here, right? Yeah, you could use different ones, but I like to use these right now. Makes life easy. I'm going to work backwards here, okay? We're going to plug in 1 first. So we got y equals 1/2 to the power of 1. Well, what's anything to the power of 1? Well, it's itself. So y equals 1/2 to the first power would just be 1/2. So when we plug in 1, we would get 1/2. Now it's going to be the fun one. This is my favorite one. Y equals 1/2 to the power of 0. Anything to the power of 0? What is that? Why, yes, it is 1. So y to the 1/2, y equals 1/2 to the power of 0 would just be 1. Now this is where things are going to get a little cuckoo. So 1/2 to the power of -1. Well, how do we negative exponents? We got to do the flip-it-a-roo. So basically we have 1 to the -1 power and 2 to the -1 power. So really what we have is we have y equals 2 to the first over 1 to the first, which then equals 2. So 1/2 to the -1 power would be just 2. Now we have our 3 points to plot. Let's do that. Let's plot our 3 points. So our first one's -1 up 2, so we're going to draw that point. Not too bad. Looks like it's about 1.8, not very good. And then we're going to draw our next one at 0, 1, right there. Still a little off. And our next one is over 1, up 1/2, so right there. It's not too bad. Again, because it's an exponential graph, we know it's going to have a curve. And we've got to remember, do not let it cross the x-axis. So we're going to draw our curve, connect through the lines. Mr. Harris, you let it cross the x-axis. Well, that's what happens when you have a fat finger drawing. There's our graph. And now we go look at the next part. What is our y-intercept? Well, let's get a nice, wonderful color here. Let's go with green. Y-intercept. Well, our y-intercept is where the graph crosses the y-axis. And our y-intercept would be 0, 1. Or you could say your y-intercept is 1. Okay, because that's where the graph is crossing. All right. So when we need to graph the following, what we need to do is we graph using our XY table. And all the practice you're going to be using today, you're going to be able to use -1, 0, and 1. You'll be able to get your 3 points, and you'll be able to see how the curve goes. Hopefully you're noticing this curve from left to right's going down, and the previous one from left to right's going up. And that leads us to our next thought. Exponential growth versus exponential decay. All right? If something has exponential growth, that means from left to right, the graph goes up. So if you look from here, if you look at growth, as we travel from the left and we go to the right, what's happening to the graph? Well, it's going up. So that's why it has growth. Growing means up. All right? Exponential decay, if you look left to right, the graph goes down. So if we look from left to right, we start on the left side and we go towards the right, what's happening to the graph? Well, it's going down. Decay means like falling apart. If something's decaying, like, compost decays, turns into things, it's going away. So you'll see the terminology, exponential growth, exponential decay. All it's saying is left to right, is it going up or down? If it's going up, it's growth. If it's going down, it's decay. All right? So let's look back at our graph. So let's look at this one. From left to right, which way is this graph going? So if I start on the left side, this is my left, all right, in case you don't know the difference between your left and your right. This side's my left, this side's my right, okay? If we look left to right, well, left to right, it's going down, so this has decay. If you look at this one, this is your left. Oh, let me get my marker, my pen here. This is my left, this is my right. If you look left to right, well, it's going up, so this has growth. And those are things you'll need to identify when you get to your practice, is you'll need to identify your exponential growth, exponential decay, which ones it's doing. Now, one of the tricky things is here, one of the things you can see here, and you'll see down here on the bottom with the exponential growth and exponential decay, is b is greater than 1 for growth, and b is between 0 and 1. So when we have that y equals, let's just use b to the power of x. I don't know where this marker came from. We have b to the power of x. If the b is bigger than 1, it's going to have growth. All right? If your b is between 0 and 1, so basically it's a fractional 1, you're going to have a decay. All right? So those are going to be keys you're going to have here. So you should be able to see. If you look, this is y equals 1/2 to the power of x. Well, 1/2 is less than 1, greater than 0. So that's why it has decay. If you look at this one, the 3 is bigger than 1. That's why it has growth. Right? So that is exponential growth, exponential decay, and graphing your exponential functions. I gotta figure out how to pause this.